Okay, today the student will be able to use the factor by grouping process in order to identify all of the factors of polynomials. Yesterday we factored sum and differences of cubes. Today we need to know how to factor if you have 4 parts. So we're going to use this method called factor by grouping. And we're going to figure out when to use it, when not to use it, and how to use it. All right? Okay. Question number 1 says, identify all the factors of the following. If I have x cubed plus 2x squared minus x equals 2. Unless you are completing the square, you always have to get all of your terms on one side of the equal sign. So it either needs to equal to y or it needs to equal to 0. So step 1, we're going to subtract 2. So minus 2 on both sides. I don't have anything that's a like term with that, so it's just going to tag onto the back. So I have an x cubed, a positive 2x squared, minus x minus 2 equals 0. Okay, now that everything's on the same side, we need to see if there's a GCD. Step 2, is there a greatest common divisor? Is there something that you can divide all 4 terms by? Well, if I look at, I have 1x cubed, 2x squared, minus x minus 2. There is nothing that all 4 of those terms share, so I'm going to skip that. Okay, step 3. We're going to split the terms in half. And here's where we do the factor by grouping, okay? Because I have 4 parts, I can factor by grouping. So I'm going to take the first 2 terms and split them apart from the second 2 terms. So I've split it in half. Okay, step 4, we're going to find the GCD of each half. So if I look at my first half, x cubed plus 2x squared, both of those have x's. In fact, both of those have 2 x's. I could take 2 x's or x squareds out of both terms. So I'm going to say that my GCD, or my greatest common divisor, is x squared. If I started with x cubed and I took x squared out of it, I'll have a single x left over. If I started with 2x squared and I took an x squared out, I have plus 2. Okay, I'm going to do the same thing with the next part. I have a negative x minus 2. If you have a subtraction sign here, if your x is negative, you're always going to take a negative out, okay? We're going to take a negative 1 out of both of these parts. So negative x divided by negative 1 is just a positive x, and negative 2 divided by negative 1 is a positive 2. Okay, now here's what's cool about this process. If you did it correctly, then the inside of your parentheses on the left, or the first half, should be the same as inside the parentheses in the second half. They're both x plus 2. And because they're both x plus 2, I know that is one of my factors. The other factor comes from my GCD. So I have x squared and minus 1. Okay? So we found the GCD of each half. We took it out. And then that led us to our factors. Okay, the next step. If you have an x squared in a factor, you need to try to factor further. And because it's x squared, then we use the factor method where we find 2 numbers that will multiply or add. Okay, so I'm going to take the x squared I still have. So I still have an x squared minus 1. And I need to see if that will factor further. So I'm going to come to the side. I'm going to take x squared minus 1 is really x squared plus 0x minus 1. A is 1, B is 0, C is negative 1. I need 2 numbers that multiply to 1 times negative 1, and add to 0. Well, I know that negative 1 times positive 1 is negative 1 and adds to 0. So I can take this and split it into two factors, x minus 1 and x plus 1. So x squared minus 1 really factors further into x minus 1 and x plus 1. So now I have three factors, x plus 2, x minus 1, and x plus 1. And that's the answer. Number 2. Negative 2x cubed minus 12x squared plus 30x plus 180 is equal to 0. First, you need to see if everything's on the same side, and it is. So if you split out your equal sign, you have everything on the left, nothing on the right. So that's good. Second, we're always going to look for a GCD of everything. So if I look at all four terms, only 3 of them have an x, so I can't say there's a GCD of x. But if my leading coefficient is negative, then we're going to say we have a negative GCD. Then if I look at my numbers, I have 2, 12, 30, and 18. Those are all divisible by 2. So I know that I could take negative 2 out of all four terms. So now I'm going to divide it. So keep the negative 2 outside, and we're going to open a parentheses and divide to figure out what's left over. So negative 2x cubed divided by negative 2 is just a single x cubed. Negative 12x squared divided by negative 2, positive 6x squared. 30x divided by negative 2 is negative 15x, and 180 divided by negative 2 is negative 90. Okay, this negative 2 is just going to kind of hang out, and it's going to show back up in our final answer, but until then, I'm going to ignore it. Now I'm going to take, I have 4 parts, I'm going to split them in half. So I have x cubed plus 6x squared, negative 15x, and negative 90. Okay, then we're going to find the GCD of each half. Okay, so x cubed plus 6x squared, those don't share any numbers, but they do share x squared. So I could take an x squared out of both of those, and I'm left with an x plus 6. So x cubed divided by x squared is a single x. 6x squared divided by x squared is 6. On the next part, the next half, I notice my x is negative, so I'm going to take out a negative number. 15 and 90 can both be divided by 15. So I'm going to take 15 out. Negative 15x divided by negative 15 is just a positive x. Negative 90 divided by negative 15 is a positive 6. Okay, now if I did it right, then my parentheses should be the same, and they are. So that's the first half, or my first factor. My second factor comes from the GCDs I took out. So after we find the GCD of each half, then we write them as factors. So x squared minus 15. Okay, now, if you have an x squared, you need to see if it factors further. So I'm going to take this x squared minus 15 factor. I'm going to come to the side. And I know that that's really x squared plus 0x minus 15. So a is 1, b is 0, c is negative 15. If I can find two numbers that multiply to negative 15 and add to 0, then I know it could factor further. So negative 15, I know I could use negative 1 and positive 15. That doesn't add to 0. I could use negative 3 and 5. That doesn't add to 0. I could use 5 and negative 3. I could flip them. Still doesn't add to 0. There are no two numbers that will multiply to negative 15 and add to 0. So that means that x squared minus 15 cannot be factored further, and you can't go any further than that. So to write the final answer, I need to bring back my negative 2 that I took out at the beginning. Then I have the factor x plus 6, and I have the factor x squared minus 15. And that's it. All right, example 3. 3x to the 5th plus 18x4 plus 27x3 equals 0. So everything is already on the left-hand side, so we're good there. So we're going to look for a GCD. Sometimes there is one, sometimes there's not. If I notice, first of all, what's weird is I only have 3 terms, not 4. So I have a 3x5, an 18x4, a 27x3. But the first thing you always need to do is find a GCD, and then you can see where to go from there. So if I look at my numbers, 3, 18, and 27, well, those can all be divided by 3. Okay, then if I look, I have x5, x4, and x3. So I could take x3 out of all of those. Okay, now let's figure out what we have left. 3x5 divided by 3x3 is just an x squared. 18 divided by 3 is a 6. x4 divided by x3 is a single x. 27 divided by 3 is 9. x3 divided by x3 is no x's left. Okay, now look at what's left over. X squared plus 6x plus 9. This is not 4 parts, so I cannot use factor by grouping. You can only use factor by grouping if you have 4 parts. This is only 3 parts. So to see if this factors, so we're going to factor what is left. But it's 3 parts and it's an x squared. So this is when I'm going to use the multiply add chart. I cannot use factor by grouping on this question. So I know A is 1, B is 6, C is 9. So I need 2 numbers that will multiply to 9, add to 6. So I know 3 and 3 would work. So I can take this and say it's really x plus 3 and x plus 3. Okay, now we're going to write the final answer. So I have 3x cubed times x plus 3 times x plus 3. But there's one more thing we can do here. X plus 3 is the exact same as x plus 3. And remember, sometimes mathematicians are kind of lazy. And if I could get away with not writing that twice, I'm going to do it. So I could say that I have 3x cubed, but then I have x plus 3 twice. So I have x plus 3 squared. And that is how you will usually see that answer written. Okay? So we could not use factor by grouping on that one. Number 4. Number 4 can be used with factor by grouping. I would pause the video, try number 4, and then turn it back on. All right, so let's see. So first, is there a GCD I can take out? No. There is nothing that these have in common. 3, 4, 6, and 8 don't share anything, and they don't all have an x. Okay, now I notice that I have 4 terms, so I'm going to start factor by grouping. So I'm going to split them in half. So I have 3x cubed plus 4x squared, negative 6x minus 8. We're going to find the GCD of both. So 3x cubed and 4x squared. 3 and 4 are not divisible by anything that's the same, but they both have an x squared, so I can divide that out. 3x cubed divided by x squared is 3x. 4x squared divided by x squared is a positive 4. Okay, now to find the GCD of the others, remember if it starts with a minus, if your lead coefficient is negative, you're always going to take out a negative number. I know that 6 and 8 are both divisible by 2. So negative 2 is my GCD. What's left over, negative 6 divided by negative 2 is a positive 3x. Negative 8 divided by negative 2 is a positive 4. If you did it right, then their 2 insides should match, and they do. So I know that 3x plus 4 is one of my factors, and the other factor is built by x squared minus 2. Okay, now you need to see, can the x squared be factored more? So if I come to the side, I know that x squared minus 2 is really x squared plus 0x minus 2. I need 2 numbers that will multiply to negative 2 and add to 0. Well, the only way you get 2 numbers to multiply to negative 2 is negative 1 times positive 2 or 1 times negative 2. and neither of those will add to 0. So this cannot be factored further, and that is my final answer. Okay, this next set has a different instruction. It says, is the following binomial a factor? Excuse me. So they give you the polynomial, and then they ask you, is x minus 2 a factor of that? Well, let's think for just a second. So let's come out to the side and just think about this. If I gave you the number 20, and I asked you, is 4 a factor? Is 4 a factor of 20? You would say yes. Because 4 times 5 is 20. But the other way to think about that is that 20 divided by 4 is 5, is a whole number. Okay, what if I said, is 3 a factor? In your head, you should be thinking, can 20 be divided by 3? No, it can't. And technically, 20 could be divided by 3, but you would end up with a decimal. 20 divided by 3 is the decimal 6.6 repeating. So it is not a factor, and you know that because 3 times nothing is going to give you 20. That is whole numbers. So we need to keep that in mind. If factors of 20 are anything that would split evenly into 20. So you're really thinking about division. So if we bring that back over here, if I want to know if x minus 2 is a factor of this polynomial, then I need to divide them. And if it divides to a whole number or no remainder, then yes, it's a factor. But if I get a remainder, then it is not a factor. Okay, so your steps for this whole thing are divide. No remainder means it is a factor. Any remainder other than 0, which would be like having no remainder, then it is not a factor. So we're just dividing. All right, so let's take x minus 2. We can use synthetic division. So x minus 2 equals 0. Add 2. So x equals 2. So we're going to use 2. And then we have 5, 4, negative 20, and negative 16. Carry the 5. 5 times 2 is 10. 14 times 2 is 28. Negative 20 plus 28 is 8. 8 times 2 is 16. Negative 16 plus 16 is 0. If it's 0, that means you have no remainder. So yes, x minus 2 is a factor. Okay? 2 more. If I want to know if this is a factor, same thing. We're going to divide. So I'm going to take x plus 3. I can solve it equal to 0 in one step. So negative 3 is what I can use for my synthetic division. On the inside, I have 2, negative 1, negative 18, and 9. Okay? So carry the 2. Negative 3 times 2 is negative 6. Negative 1 plus negative 6 is negative 7. Negative 7 times 3 is positive 21. Negative 18 plus 21 is 3. 3 times negative 3 is negative 9. 9 and negative 9 is 0. There is no remainder. So yes, x plus 3 is a factor. Okay, last example. I want to know, is it a factor? So we're going to divide. So x minus 5 can be set equal to 0 and solved in one step. X equals 5, so that's what I'm going to use for my division. So I have 10 negative 41, 32, and 20. Okay, so carry the 10. 5 times 10 is 50. Negative 41 plus 50 is 9. 9 times 5 is 45. 32 plus 45 is 77. 77 times 5 is 385. Add that to 20, you get 405. I have a remainder of 405. So no, x minus 5 is not a factor. And that's it.